Well, hello everyone. It's Michael McClellan, Levine Electronics and Electric. Welcome to another lunchtime webinar. We're so happy you could join us today. Today we are very lucky to have on the calendar Joey Hammock, who is one of the senior application engineers at Danfoss. And Joey's going to tell you a little bit about himself in a minute, but I just know that he's been with Danfoss a long time, has seen all kinds of different applications with regards to motion control, pumping, you name it. And so you can ask him any question you can think of, try to stump him. I hope you guys will ask some questions. This is a webinar in webcast format, so your phones are muted. We do that to take care of the barking dogs in the background and things like that. So there's a icon to the left of your screen, I believe. It's either has a question mark on it, maybe a magnifying glass, and we would love for you to use that question box and ask questions and make this interactive. Joey has a wealth of knowledge to share. It just needs to be pulled out of him. So that is all I have for today, and I'm going to turn it over to Joey.
Hello, my name is Joey Hammock. I am Senior Application Engineer at Danfoss Drives. I've been with Danfoss for 18 years now. Well, 19, going on 19 actually, but been with Danfoss from working on the drives, getting my hands dirty, to tech support for many years, and now I'm in applications, and I've been in applications for over 5, but been all over the world essentially, applying drives to different applications, including soft starters in this case, and seeing wastewater treatment plants to machine packaging, food and beverage, industrial, and HVAC. So moving on, in this case, this webinar, we're going to talk about how to select the soft starters as far as, based on different applications and stuff. In this webinar, I'm going to mostly go over utilizing our latest soft starter that Danfoss has in our portfolio, which is the MCD 600. And then selections, which I made a mistake. Our previous one was the 500s, but we're going to do the 600s. The tools that we use, and also we're going to talk about some of the steps we take to, using what data we have and some customer information to picking the right soft starter. And then I have a few exercises, some examples of choosing it, utilizing some of these tools, and then I'll go over some of the answers and some of the data that we found to help pick these particular sizes. First off, for this particular soft starter, it's the MCD 600. It's our newest soft starter in our series in 3-phase soft starters. It offers a lot of advanced features and stuff for motor control, protection, and fixed speed applications. I do want to mention that a lot of, including our marketing of this, we call it the single speed drive. We have VLTs or VFD drives, which are variable speed, but soft starters are typically 1 speed. And I do see there's a question there, what COM cards do they have? Profibus, Profinet, Ethernet IP. I can go over some of the other features and options that we do have later on, but yes, we do have Ethernet IP, Profinet, and so forth. I do have a secondary presentation if we have time to go over different features. But in this one, we're going to start off with selecting or properly sizing one. Other features that it does have is there's smart features, application type of things, and field bus as it says down there, though serial and Ethernet based. In this particular series, though, we do have different current rating soft starters, and that is part of the type code. In most soft starters, I'd say you do select them based on their current rating, and that current rating does vary based on the starting currents that we need. The part of the code that this particular soft starter has internally bypassed contactors, and what that means is this is a voltage limiting soft starter, or as also with the voltage limiting is current limiting. That's how we soft start a motor. But once it's done going through the starting profile, we get to full speed and current drops off. It then has contactors on for all three phases that close. So then the motor is essentially connected to the line through the soft starter. The soft starter is still monitoring current for protection and other application features. This particular soft starter is considered a closed loop soft starter, as it is utilizing current feedback through current sensors inside to control the current that is being fed to the motor. Different frame sizes, as we're still advancing, there will be bigger ones later on in the year or years to come. Two different voltage ranges. Typically around the US, we'll have 200 to 525 volt. That will range that can handle 208, 230, 460. And then some of the higher ones, 380 to 690. Usually you'd have that like up in Canada to the 575s and the 690 volt ranges. A couple of IP ratings with this, IP00 and IP20, generally designed to be inside cabinets and such. There are add-on options to make this NEMA 1. IP21 is or even, I think mostly, I don't think we do NEMA 12 or anything like that. That would take having a cabinet. And a couple of control voltages. This is the control voltage that controls the start, stopping, and the control part of it, not necessarily the line part. And that can be connected up to a 24 volt AC or DC connection, or a 110 or 240 AC connection.
Hey, Joey, a question came
Yes.
in.
Yes.
Does this soft starter have 6 thyristors?
This soft starters is using thyristors or SCR controls. There are 3 modules, but yes, it's total of 6. So there's a positive and negative for each phase. So full wave control. Some soft starters, which we do have a series, which is the MCD 202, which only has 4. The middle one's just a straight through bar. Not all 3 phases are controlled using the control loop, but this particular one is all 3 phases. So basically, selecting your soft starter, one thing, the size of the soft starter must match the motor and the application. Selecting the soft starter that has the current rating at least equal to the motor's full load current rating. Now, some of that can move around based on different things. As you see, there is a specification that is applied to starting the IEC, in this case, the AC 53B code, B for bypassed soft starters. There's an A for ones that are constant control. But this one being internally bypassed, you have the B code. But both of them have the current limiting rating, how many amps of the rate that the soft starter can handle. Then also you have the starting current, which is a multiple of the full load current. So generally when we talk about light duty, medium duty, and heavy duty, kind of goes with this. So some light duty applications will require 3 to 3.5 or 300 to 350% of full load current. Some medium duties are 400, and heavy duty is more up in the 4.5, 450% to 500% full load current. And I have a table here that I will share that shows typical of different types of motors or different types of applications or devices that we're connecting a motor to, of how much current it needs. Now, generally across the line, a motor across the line will start, of course, very quickly, but that it will demand somewhere around, could be from 600, 700%, upwards to 900% of the motor's rated current. So going back to this, as far as we have the starting current, and then that also has an effect is the starting time that is needed to softly start the application or the motor. This could be somewhere 10 seconds up to 30 seconds. And then there's also an off time. And this is the balance between heating of the soft starter for how long it took to start, and then cooling time, and that has an effect on our selection. So like the soft starter's current rating does determine the maximum motor size it can be used with, and that's in the table stuff that I will show. Let's see, I kind of went all through all this already. So moving on, some of the tools that we have for the soft starters that we have communication setups, setup tools, which is our Danfoss MCT10 setup software. I will review that with you. WinStart. WinStart is a sizing program. Yes, go ahead.
A question came in regarding that. What are the communications options? Do we offer Profibus, Profinet, Ethernet IP? What are the options?
Okay, let me just skip on over to that here. Let's see. I lost my control panel stuff because I was clicking on something. Give me 1 second. View. There we go. There we go. Can you see this one of the feature set?
Yes.
Okay. So over here, as optional features and stuff, the serial communications is showing that we do have DeviceNet, Modbus RTU, Profibus through these serial comms, and then over Ethernet communication, we have Ethernet IP, Profinet, and Modbus TCP option cards. Other functions that are, since we're going through that, it does have a quick setup, built-in metering and input and outputs of it, multi-language displays, real-time graphs built into the display. One new thing that I have learned on this that is pretty nice for setting it up, and I don't see it on here, is it has a test mode as it would be. So when you set up your controls, wire in your inputs and stuff, you can put the soft start in a test mode, and you can see the display and watch it, make sure that it functions without starting the motor. So it kind of does a demo mode internally and doesn't actually keep starting and stopping the motor. You can see the run indications and look through the display and stuff that all your controls are operating before enabling the soft starter for real functionality. But this soft starter does have different options built into it. So it has scheduling, start and stop, adaptive current control or constant current, the pump clean or derag, that term is used. Different ones, ramp to stop or coast to stop. It has DC braking ability and soft braking. And it also has a reversing function, kind of a jogging, or can run backwards. Other things that are helpful in this, as it has protection. It has motor overloads protection built into it, an excess of start time function. In case the motor is blocked or something, you can actually have the drive trip based on how long it's taking to start the motor. Undercurrent and overcurrent protection, overpower protection, current and balance, input trip, also phase rotation trip if something changes, utility changes, so that the motor doesn't accidentally start running backwards. And thermistor input, again, based on motor temperature. A lot of these, as far as undercurrent and overcurrent and power, is an adjustable setting in the soft starter.
Kind of interesting. Can you explain what the soft brake is?
It is utilizing the input phasing, and it is actually firing them in a way to, and also limiting the voltage going to the motor to basically stop, I guess, as far as braking the motor. I'd have to look at that personally. I wonder if it's more of during starting, can it fire it to try to brake it before starting in case it's like rotating backwards. All right.
Great. And question came in, how does it accomplish the reverse direction?
It is another firing sequence, because yes, we are connected to the input. Of course, it has a clockwise rotation, but that's why I call it a kind of jogging. So it fires the SCRs in a manner that is mimicking a firing order that the motor is seeing, that it is making the soft starter run backwards. I don't know if I'm explaining that well, but that's kind of my take on it, that I've seen it, that how it fires it out of order in a way when the peak of the wave's coming by to make the motor start jogging backwards. Okay. Are you seeing the screen now that says the tools? Well, I guess I can actually see my audience view. Ah, yes. Okay, I can see where I'm at. All right. Any other questions before I move on? Okay. So MCT10 is our setup tool that we use for setting up drives, but we can also use it to set up soft starters. In the case of the MCD 600, we have implemented that back in version 4.40, and I believe we're at 5.10 now. But at any version previously, if you already have MCT10, you have that function already. Now, in the case of the MCD 600, you do have to add a soft starter connection, and I will show that here. Oops, come on. There we go. So under network, you can add and remove, and there is a add function for different types of connections, as well as we can do Profibus, serial, Ethernet connections to drives, and through a wireless LCP. but there is an Ethernet connection or a serial connection to soft starters. And it will say serial all AUCOM or Ethernet AUCOM. You pick that out and you can give it a unique name. In my case, I just called it soft starter. And then you can add to it a soft starter, which I've already done here. I just called it soft. Pick a size and you get the parameter list in here. Now with the 600 series, the parameters are loaded and saved via a USB connection, as well as or a USB thumb drive kind of file functionality. Let me change back. Where was I? Oh, not on the presenting. There we go. So through a USB thumbstick. So as you do your files, you would, okay. So again, once you have all your parameters set, you can right click on the project or on the MCD and you can export it to a parameter file that can be loaded on the USB stick. Same way in the soft starter, you can pull the parameters and import it into MCT10. Go back here. The tool is free. The MCT10 setup software is free to download on our Danfoss Drives website. Another tool that I've mentioned is the WinStart program. There are two available out there. There's a WinStart for our older generation of soft starters, the MCD 200 and 500. And then there's one now for the MCD 600 and more updated version. It has a couple of different functionalities built into it. You can use it to find the max full load current of a particular soft starter if you have one. You could also use it to select a model for a certain application. One thing is we were mentioning earlier as far as how much starting current do I need for the application. In the program, it has your ability to load if you know already, but there is a selectable application and it will autofill typical things, but it will tell you what the starting current is, and it will fill in some times, but you can modify these settings and it will change which soft starter is proper for that particular application. This is again a free download on our Danfoss Drives website. Utilizing this tool, you can, you pick, in finding the full load current, pick a model, the voltage. You can pick an application, it will fill this in, or you can enter it in and it will give you the ratings as we're talking about down here. It will also give you the dissipated watts at full load current for sizing panels that you're putting it in. There is also a panel sizing or airflow function built into this new version of WinStart. So in this one, as it shows, like selecting the model, again, you can select an application, the voltage rating, and selecting this will, and you can select the motor rated current in here, but then it will fill in these, but you can change the starts per hour. It will autofill in the starting current, but you can change that if need to be, the starting time necessary, stopping time, or if you're coasting the stop, the ambient temperature that's going to be in, and the altitude. And it will give you the power dissipated here and the model number at the bottom. You can also select an inside delta connection. one of the questions I've had, and that I get that too, what is an inside delta connection? Some people know, some people don't. I was looking actually a little bit for what is an inside delta connection. I did find a pretty good explanation here from one website. You know, our friend Google can find all, but an inside delta connection is a 6-wire motor. Generally, it's got the 3-phase windings, and they are individual. You can get to both sides of them. Typically designed or for use with star delta starters. This actually helps if this is the type of motor. You can use a soft starter with it instead. The thing is with that the importance of selecting that, it can, because it's only handling kind of half the current going through, you can get away with a smaller soft starter. That's why that is a selection for connecting or picking the soft starter. If it's a star delta, you can basically almost half it in a way. Kind of a look at how a star delta connection is, and as you have the 3 connections, it will connect it in a star for starting and then change over to delta for run. When you're connecting a soft starter, we are in the delta mode, and then just limiting current for the starting. Let's see. Okay. This particular the connection of the soft starter is available in the instruction manual. There we go. So it's one of the pages here as far as, you know, standard inline connection, inside delta. So as we saw the other one, where one side of that is connected for the 3 coils direct to the line, the other side going through the soft starter. Instead of switching between connecting the lines between star and delta, we are feeding it in line to half of the coils. This is one of the tables that I have that's in one of my older manuals. It does give general different applications and what is the typical starting current for each application. Picking it in the WinStart will do the same thing. We'll fill in these typical numbers. There's also some guides that we have available that you may see from different. Let me find one here. There's one that I did share. One of the guides I want to bring up is this guide here. Has an easy table based on some horsepowers, but you do have your full load current ratings and then which soft starter is. Now these tables here in this one is assuming a couple of things in here. These selections will get you right about where you need. This is kind of a handy guide for picking, but it sometimes will be at least maybe a little bit larger. I would use the WinStart to get more of an accurate selection, but if not knowing some of the things as far as the ramp time and starts per hour, this is a pretty good table for picking. Again, we get to what is the different duties, and this is where some of the selection guides that we have out there will have kind of the same kind of situation based on different types of applications. And this one goes by telling you inertia, which I would say that's a, you know, more the weight, the more current it needs to start. So this would be a heavy duty, and the ones not listed would be a standard one. That, again, with this in combination with a table, whether it's standard duty or heavy duty, which soft starter do I pick? But again, I always do want to say we always pick them in relation to their current ratings, but you know, current and horsepower kind of go hand in hand. Another function in the WinStart software is the ventilation enclosure kind of cooling calculator in there. And you can calculate based on metric units or imperial units, inches or degrees Fahrenheit. So in there, you kind of put in what your cabinet size you have, the power dissipated, which we found from the soft starter itself, and then it will give you the enclosure surface, their internal rise time. If the rise time is less on what you want, you know, like in this one, it shows 743. So this would be the temperature in degrees C in this particular case, doing nothing or no kind of fans. But if we need it to be, don't go higher than 5 degrees rise, then it tells you the minimum airflow that you need to ventilate the cabinet. So some of the, I'm going to go ahead and demonstrate with the software some of the scenarios here that we're going to size a soft starter. So let me exit that. And I thought I already had it running, but I will start my WinStart. And I'll show choosing this at different tables and such. But in this case, so we're going to size. So in this scenario, we have a customer with a 110 kilowatt screw compressor or 210 amps. We know this already from the customer, though. It uses 350%, and we can also verify that in here. And they want to start for 15 seconds, and the duty cycle is expected to be 4 starts per hour. So we go here to starters. We're going to pick our soft starter, and we're going to pick select model. And here, as I said, there's different applications. So in this case, we're going to do a screw compressor. And there's 2 different kinds in here. There's starting loaded and starting unloaded. Most of these will have an unloader to start running. So we're going to go ahead and pick unloaded. And you see it did put the starting current here at 300%, or 350, excuse me. If I do like the heavier duty one, if I do loaded, a little more current's needed to start. You can see starting current's 400% here. But I'm going to go unloaded. Current rating of the motor, 210 amps. And you see the number here is changing down here at the bottom. 4 starts. Then I do have to click to another one for this to update down here. And my start time is 15. It gives us what our power dissipation in watts and our model. So in this case, it needs a 244 amp rated soft starter. Now we could have possibly did this in the tables. If we look at like the quick guide here, whoops, right? There we go. So at a 460 volt, what did we say? That was kilowatts, but we'll do the current. So say it's about a standard duty. This one gives us a little bit bigger size. It goes 1 size bigger. This is because of the assumptions down here. We're close. 15 seconds is less time, less heating of the soft starter. If it needed 30 seconds, we need to go a little bigger to handle the temperatures or the heating of it. But I'd say in most cases, if I, some of them will go, I would not go a rating necessarily less too often than the motor is sized. I do have some where quick and that this one size smaller may make it, but I'd say for things that change and wear and tear, sometimes I do go, if it goes one size smaller, I do go with the one, at least it's rated for the full load current of the motor. In the actual operating instructions, there is installation, specifications. I know I had one in here that I had, here we go. There it is, selection of soft starter. Gives you the same information for IEC ratings and gives you the same part so you can kind of pick based on starting current, time, and off time. A lot of times I pay attention to the starting current and start time. And as long as this number is at least higher than the motor rating, you can pick your soft starter. And you see with this low current for 10 seconds, you do see this 108 can handle 172 starting or motor current. There is also, I think the other tables are, as we have IEC tables, here's your NEMA tables, and that is what the guide or our quick guide there is picking based on horsepower, motor current, and then you have your soft starter size. Kind of quicker guide depending on how many starts and time. But this will give you exact, kind of down to the amp. All right. Let's take another scenario. Any kind of questions at this point as I kind of demonstrate just a little bit of a selection and kind of give you different options, but kind of why there are different options as far as on paper. You know, it's assuming a couple things. You can get a little bit more closer to that in the instruction manual, but the software gives you a little more parameters to play with and you get a proper selection. What is the max delay retards in seconds? It's a good one. So in the parameters, I already have it up in MCT10. So my start time, oh, I have a screen in my way. There we go. 3 minutes. Now this, I'd say in the settings in the soft starter is more of a limiter or monitoring as that, because how long it takes a motor to start is going to be based on my initial current and my current limit, how many percent I'm setting to it. Basically, whatever I'm limiting the current, the application will kind of determine how long it takes that motor to get to full start. Of course, the higher I set this limit, the faster that motor's going to start. This will more monitor as far as if it's starting to take too long to start from what I've set. And as I was saying, the other protections built into it, we have selectable protection limits as far as we were talking the current imbalance, undercurrent, overcurrent, under voltage, over voltage, under power, over power, excessive start time, restart delay, and starts per hour. That's a good one. How does it handle a thyristor short? The MCD 600 does have a unique feature in it, actually. If one of the thyristors short, it can alert you that one of them has failed, but it will go into a two-pole control mode. It will actually close that contactor and you will still be able to start through 2, but it will give you time to do a replacement while the soft starter has been damaged. Now, that's a good brought up point, as I showed with the inside delta. We do suggest for soft starters to have a isolation contactor in front of it. The soft starter can control it for starting and stopping to close it before running sequence, and once it comes to a stop, it can open it. Reason being is because through SCRs and the filtering, even at stop mode, there will be voltage or leakage voltage seen on the output. For safety, it is suggested to have an isolation contactor in front of it so that there's no voltage shown on the output. All right. Scenario number 2. We have a conveyor here, 35 or 85 amp conveyor. Start time is 15 seconds, 50% duty cycle, 15 starts per hour. This one has inside delta is possible. And then ambient temperature is 47 degrees. So we will make a change here. We will do a conveyor. And looking at this, we can see it, say it's a belt. Okay, a little more heavy duty right away, 450% we see here. Current is 85 amps. Doing 15 starts per hour. And see the change here. I will go back to this. It was 4 when we had. At first it was 144 amp. Starting many times, it's going to warm it up. It needs to handle more temp, higher current. Change it to 171 amp. Start time is 15 seconds. Brought it down again. We're not spending a lot of time heating up. Remember, these are internally bypassed. It allows it to be a little smaller and cooler when it's in the bypass mode. We're not firing the SCRs all the time, only during start and stops. I didn't remember to do the temp. Temp actually brought it up. It's a hotter environment. So now our pick is the 144 amp soft starter. Now we do have an inside delta connection possible. Not handling much of the current now with the inside delta. Now it goes to 108. So if we are able to connect this motor with an inside delta connection, we can put a smaller soft starter in there. But if it's not possible, 144.
Joey, you didn't put the stop time.
Did we have stop time in here? We can do that. We can coast to stop or stop time 15 seconds. That brought it up some more heating. 171. Inside delta, 108. So this, all the calculations as we're changing, it is changing which one are we picking. I will say at the end of this presentation, I made a mistake in my calculations here because I forgot the temperature in this example, just so you know. Okay, it's down here. When I get to the end, I have what my answers were. And this was because I forgot the temp. Scenario 4, or 3. Kind of the same kind of motor earlier, but in this case, same as scenario 1, but now we're using, instead of a What was the first one? A screw compressor. We're now using a reciprocating compressor, and we are using a inside delta connection. We can use the manual for help in this case. Now, a reciprocating compressor is big pistons, a lot of inertia, kind of squeezing air. If I was using the manual in this case, and what was I just go to that and just go, let's pick there. Now we know it's a heavy duty inside delta. So we do have a table for inline installation here, or inside delta. We know we're at the heavy duty range, and it was 210 amps. This one's a little too low, so I would 235. We're talking the time. I could probably go down a little bit here, so I can go a little bit smaller here and utilize this soft starter. Now it depends on, see, I have 4 times current here, or if it's heavy duty, I think it might be more in here. So yeah, 171B. So these are the motor rated currents that I'm using based on these rating numbers. So I'm kind of going backwards, right? If I use this, we can see a difference here. So we had before a screw compressor. I'll change the numbers back. What do we have, 4? 15 seconds. And we're just coasting to a stop in that case. I can even check mark that, it just zeroes it out. Remember we had the 171. Now I'm going to change it to reciprocating compressor, unloaded we'll say. Change it to 400% starting, and it upped the size for that to accommodate that. Oh, we didn't get our time here. 15 seconds. I don't think that made much of a difference. Oh, it brought it down. So I was right from the table. 171. When I said that the amps here, 171. Utilize a 10-second start. If I wanted a 20-second start, that's a little too small. I have to go up in the size. But see where the software, I only have 10-second or 20-second. If I could get down to it, I can use the software to kind of determine. If I'm not sure, though, I would side on a little bit higher, the higher one, if I'm kind of between it. Okay. All right. Third scenario, fourth scenario. Same kind of motor before again. This time we're going to use a submersible pump. So let's see. What is a submersible pump starting current? Would that be heavy duty or light duty? I can kind of look at a selection guide, kind of take a look at if I have those tables in here. Hello. Ah, not that one. Not that one. It was this one, I think. Let's make this smaller. Yeah, this is. There we go. What do we got? A submersible pump. There we go. It seems to be a normal duty. I can put it in here. Being we're using this anyway, let's go down to pump. And I got different ones in here. I got a submersible, centrifugal, positive displacement, or a slurry pump. Let's do a submersible. popped it at 300%. It's pretty light duty start in this one. They also made it smaller here. We're not doing an inside delta connection in that one. Brought it up in amps. 210 amps still can use 194 amp soft starter. Do we need more starting time? Numbers change. So the software does make it easy to help pick different soft starters based on different starting current, different applications and such. If you are also picking that, we do have a copy or print this out, and it will print out, same as here. This is actually a copy from it and pasted right in here as I'm getting ready for this at 1 o'clock in the morning. But, but I did the screw compressor, the first one, and it added a little more, including printing out this IEC rating. So even though the basic current as we printed on the label unit's at 244 amp, but that's based on some other, standard starting, but it can handle 249. So it's a little bit higher rated based on the starting conditions and the power, and it also gives you the watts that it's going to displace. And that's all I have for you today as far as selecting and sizing of a soft starter.
Joey, there's a couple other questions. I don't know if you want to address them or not.
Sure. Let me find that. I'm not looking at it. Let me go to the questions.
While he's looking at that, there's 4 handouts there. If you want to download them, one of them is actually his PowerPoint presentation, which we will have this posted on our website. So you can also get it from there, and I'll have the video if you want to review anything else.
All right.
I put answered by several ones you've already covered.
I'm having trouble getting this to show up now.
Right. You can drag it to a different part.
Oh, okay.
I drag it out of the column so it's easier to read and make it bigger.
I had it in the main screen, and I think either it's there or I lost it. And I closed it, and I think I lost the connection to it. Can you read it to me? I'm sorry, I can't see it now.
Sure. Actually, I saw it when you just did it. It was next to the bottom.
Oh.
Oh,
you can see my screen on here?
Yeah. Show your fields, all your fields. I'll show you which one it is. Alt tab. Show them all.
Oh.
It's anyway.
Oh. I see.
Well, no.
Now it just went away, huh?
No, it was the first one. It's probably hidden behind it.
Oh, it's probably, this thing does close that. Let's close some windows here.
Yeah, it's just hidden back there.
Boop. So I probably stuck it, no, I messed up somehow. So.
Is there a way to get the MC600 with line connections on the top? This is easier for a retrofit application.
Let me see here. And I think they're all on the bottom.
Some of the drives we have like a side mount kit you can do.
Yeah. There used to be the other one, which I know the 500 has the ability to move them. I think the smaller ones, they're all on the bottom, or they went through top to bottom. I think not in this one because of the smart card and the digital inputs are on the top. So they're trying to kind of keep with the, there's kind of safety ratings. You can't mix digital, the low voltage and high voltage connections, or they got to be separated with that. But it's also the way the card is, all the options now slide into the top, and that takes up the room unfortunately. I think when we get to the bigger ones, then yeah, because the control will be more on the side, it'll be more like the older ones with there's more bigger bars and they'll be movable from top to bottom. But these smaller ones with the internally bypass, it's all on the bottom and they're pretty small actually.
I'm not sure you answered this or not, but how do we handle the thyristor shorting? An isolation contactor, question mark?
Yeah, this was the one I mentioned that the 600 has this ability to, if one of the SCRs fail, it will basically close the bypass contactor internal to it, and it will do kind of like the MCD 200 where we have two controlled phases. So it will still stop the motor and soft start it, as well as alert you that there's damage to the soft starter, but it won't stop your application from functioning. And it also, you can schedule replacement.
Excellent. The last question, and I guess I wasn't paying attention. He said somebody thought you had mentioned medium voltage soft starts.
No, I didn't mention
All
that.
low,
I did
all
say that.
low.
Yeah, I don't think we do the medium voltage soft starter at this time.
At this time. Okay. Joey, there's no other questions. You did an awesome job. It is always, there's a lot of different ways to size these soft starts and you get different answers. We've literally doubled the amperage.
I tried to show all the ones. I know most of this, and I had a complaint that this table oversizes them. But this is using the NEMA, which is more in the US, and also doing the horsepower. And in some cases, bigger is better. I hate to have one in the field that's undersized and then it doesn't work. It becomes more of a headache. And that's why a little bit that I caution at some when there's a split just by a size. Some of these are physically the same size anyway. And I know there's a cost difference in some of it, but if there's any questions, please feel free to give us a call and we can look over all of the conditions and pick the right one, especially if we're talking a difference of $1,000 or something, even in that case. But if, you know, the budget is there and stuff like that, and it's on the hair on that, and because things do change over time, you know, sizing some things right to the limit can hurt you later, I would say, and sometimes. But
Right.
the software does take that into consideration. That's where it sizes it properly and stuff like that too. So sometimes on paper, that's where I do like the software. It does pick it right for the right, and you can play with some of the numbers and make a somewhat educated decision.
Okay, great. Michael just put up a poll question.
Mm-hmm.
So why would you use a soft start instead of a drive? So I'll give you all a second to answer that question. And then we've got one more poll question.
Yeah, I'd like to.
Like to know?
Yeah, I have some, well, I have some of my own thoughts on that. I do know that we have customers that use drives and soft starters together. We have we sell soft starters because there's a lot of applications that are single speed.
Right.
For instance, even some with the cascade function of the Aqua Drive and some water things, you can have the one drive modulating one pump, and then it cascades in single speed pumps, basically making it like one giant pump, and you still get variable flow with the combination of fixed speed and the one variable speed. So you don't have to have multiple drives. You can have one drive with multiple soft starters.
Yeah, we've also done jobs where you needed to start 3 pumps. You didn't want to start them all together. So
Yes.
I can start the first pump, bring it up to speed, and if the soft start, go to the second pump with a contactor, bring it up to speed, and then go to the third motor and bring it up to speed. So Yeah, we can do that kind of things too. All right, I'm going to go ahead and close this poll question and open up the last poll question, Michael Scott. Would you be more likely to push a soft start if it included a DRAG or a pump clearing function? Was his last question.
I saw the other one. No one picked price, which is good. I mean, simplicity is a good one. Most of them was simplicity. There was a lot of others. Could be application. And what's nice is, like I said, the technology is still moving forward, even in soft starters, as simple as they are. I like to call them current limiting contactors, but you get the protection and other features in there, like now DRAG is one, and field bus monitoring. I've actually at one time installed drives where soft starters could have been fine there, but it was because of field bus connectivity they needed, because we didn't have it at the time, or it didn't exist at the time for soft starters. They were more simple contactor type of devices.
On the other hand, drives are becoming so inexpensive. The price differential on some of them is not that much. So
yep,
you can actually get the advantage of a drive and save energy if your application can handle it.
Mm-hmm.
Yep.
You still have some more flexibility with drives, especially with the like I said, with the variable speed functionality.
Right. Exactly.
But it is a more expensive option when we compare it right to soft starters.
Well, interesting enough, where 57% said yes to this DRAG.
Mm-hmm.
Yeah, that's interesting. Okay, good. All right, it's been 2 minutes. I'm going to go ahead and close that last poll.
Okay.
Joey, thank you. You did an awesome job as always. You're one of my favorite speakers.
Well, thank you very much. I appreciate that.
Thanks everybody for attending. Have a great day.
Thank you.
Bye-bye.
Bye-bye.